Everyone. Welcome back to our course on computer vision. I'm Conceivably your instructor, and today we are going to talk about translation or shifting of images. So translation means basically shifting, as I've said, means so we can shift our images. Like if you are seeing an image, we can shift it towards right side or the left side, or maybe bottom, top, or maybe even diagonal. We can shift it. Okay. Now basically we do this translation just to like you want to hide a certain part of the image from the sides, or you want to crop the image out, or maybe you want to create some kind of an animation with the movement of the image inside of that window. You want to create some kind of an animation. So for all these puzzles we use this translation. So let's get into our spider ID and see how we are gonna do this. Okay, so here we are. This is our spider ID. Let's zoom it so you can see. Okay, so we are importing just two general our library CV2 and NumPy, and we are reading the same image lena1.jpg, and we have used this image1.shape so that we are dividing the row into row. We are like dividing the rows inside of the row variable, columns, number of columns inside the column variable, and number of channels inside the channel variable. Then we are using cv2.imshow for frame 1 image 1. We are printing or showing the image 1, and this is cv2.imshow for image 2 that we are going to create after transformation, after translation of that image, after shifting of that image, whatever image later we get, which will be stored in image 2. And then this is wait key and destroy all windows that you know very well what they do. So let's talk about how we do translation. Now, if you have studied in the maths or in the graphs, you would have seen how we move the whatever the graph that we have made towards axes, like towards x-axis, towards y-axis, or maybe towards both of them and the diagonal. We move our graph. Okay, so what we do is basically we change the values of the x-axis or the y-axis and change the origin. So same thing we are going to do it with the help of our one very popular matrix called translation matrix. So translation matrix basically looks like, let me show you. Okay, over here, translation matrix is defined as T equals to, and it looks like 1 0 x and 0, okay, 0 1 5. So this looks like a matrix. Okay, it is a matrix which is 3 by 2 matrix. Sorry, 2 by 3 matrix where 1 0 and x, and there are two rows, 1 0 and x, and 0 1 y with 3 columns. Okay, 1 0 0 1 are just the numbers, and x and y are the axes to how much we are gonna shift it in what direction. Okay, that is what is defined inside of the x and y. Now to use this translation matrix, so we will create this translation matrix. Right now this is just a explanations format. Let me zoom it so that you can see better. Okay, this is just to explain you, but we have, if you are using a programming language, we have to create our own matrix, translation matrix. And how we're gonna do it? We're gonna create our array. Matrix is a array already, so we're gonna create our array. T is equals to, now to create an array, we use a numpy method, np.float, float 64 or float 32, you can use any. So I'm using float 64. Now we're gonna write the matrix over here. Okay, so first we have we talked about, oh sorry, I got deleted it. Let me write it again. T equals to 1 0 x and 0 1 y. Okay, so in the first row there is 1 0 and x, so we're gonna write it 1 comma 0 comma x, and in the second we have 0 1 y, so we're gonna write 0 comma 1 comma y. Okay, so this is our translation, this is our matrix, which is which we call a translation matrix. Now to apply this translation matrix, to apply this whole concept, there is a method in the OpenCV which is called cv2.warp-affine. Now warp-affine, why? Because these translations or other methods that we are going, other things that we are going to study later in the course, like rotation, scaling, these are all comes under the affine transformations in which we don't destroy the image, we keep the image as is. We don't basically we don't destroy the image. So same thing is here. This is our affine function. So we are using this warp affine method of CV2. So we are create image 2 whatever the image that will be found will be kept at image 2, and we are going to use the method CV2.warp affine. And warp affine takes some parameters, like first it takes the source image, whatever the image we are going to warp affine it. Okay, second, okay, wait a minute. It is giving us a description, but because of the zoom, you can see it. Let me write it again so that you can see it properly. Warp affine. Okay, first is the source image. So I'm gonna write image 1, and second one is the, you see here. First is the source image at the top. You can see SRC source image. So we have given image 1. Then is the M. M means a matrix. So our matrix is T, translation matrix. So we're gonna give it T. Then it says destination size, the size of the destination image that is going to be formed. So it will be obviously column comma row, because we want the original image, right? So we have created our image 2, and we have we have already used written cv2.am show frame to image 2. So I think our program is already completed. Now let's run this program. F9. Okay, name x is not defined. Yeah, we haven't defined the x and y's, right? So x and y's, we can give it any values. X and y basically means how much we are shifting, in what direction we are shifting. So we can give it any value, like we can say, oh, let's say 50 comma 60, or let's give it a bigger number so that we can see clearly, 50 comma 80. Okay, now let's run this. Oh, we want to remove this also. This is not Python. Okay, now we have our subset 2 frames. You see, this frame 1 is our original frame, and frame 2 is the frame in which we have shifted the image somewhat far. Okay, so you see, we have used plus 50 and a plus 80. So plus 50, it's shifted towards the right side for about 50 pixels, and plus 80, it shifted in the y-axis downwards by 80 pixels. So those x and y are basically, we can say that in the form in images you can call them as pixels. So this shift is 50 and this is 80. Same way we can do it. We can change these values. Let's say let's give it minus. Control A F9, and you see the image is shifted towards the left side. Okay, and same thing is with the bottom. Same way we can do the more changes, or we can make it minus also. And let's see it again, and this time the image is going upside and towards the left side. So this is called the translation of images. Now I have told you we can also create an animation with the help of this translation concept, right? So let's create a animation of it. Okay, so for the animation, what we need a continuous movement of that image, right now we are seeing just one fixed position, but what we want to keep changing it. That's how we are going to create a animation of an image, movement of, we're going to see the live movement of that image, just if it keeps on changing its position one step by step. So to do so, we know there is a concept called loops that we are going to have to apply. So let's apply loop. Let's say while, and make it true. While true, until the condition is true, it is gonna run. And let's create a whole indentation. Okay, so this comes under indentation part, and we have to put a break statement in the while. So let's keep k is equal to cv2.wait key, and we're gonna create a if k equals to ord a. Sorry, let's use q quit, then break. Okay, this is done, and let's make it right now initially 0 and 0. Okay, and we're gonna use it uh, after showing the images. What it's gonna do is let's use it here. It's gonna x is equals to x plus 1 and y equals to y plus 1. Okay, so what happens every time a loop runs, value of the x is increased by 1, and we can see that let's see what happens. I'm not gonna break the bubble for you. Let you see. Okay, invalid syntax. Yep, a colon over here. Let's see if there's any other. No, you see the image is moving. Let me show you again. F9. You see the image how it has been moving. Okay, same thing. You can. Wait a minute. Yep. Now same thing. If I reduce the speed of it like 0.1, let's say 0.1. Now if we see it, now you can see it clearly that our image is moving to the bottom side slowly. This is an animation. You can change the speed like this. Okay, let's close it. Now we can also do like and the image is going in that direction, or maybe you don't want to put y-axis. Let's remove the y-axis. Okay, you don't want to change the y-axis. Now let's see, moving towards the x-axis. See, now this is all about translation of images. You see how you can do the animation. You can create different kind of animation. You can even do like y is equal to y plus 1. Now let's see in where this image is gonna go. See how this image, if you see it again, you see the pattern that image is, the way image is going bottom fast and left side real slow. So that's why its position towards the disappearing point changes. Okay, because if we would have also increased the speed of it, then it would have gone diagonal. But what we did here, we reduced its speed. We make its speed like, let's reduce it to half. And now see, it is not going diagonal perfectly, it is going somewhat bottom. Or if you more reduce it, like make it 2. Now see this image is not going for the diagonal, this image is going to the bottom side of the window. So this is all about in the translation of images. And try practicing, keep practicing it, try to find much better way of doing all of this thing. Okay, and see you in the next video.